Hi everybody. In this video, I'm going to be talking about balancing equations. So before we really talk about balancing equations, we need to talk about why. So the law of conservation of mass states that atoms get rearranged but never created or destroyed. What that means is that whatever you start with in a reaction, it also has to appear in the products. So equations must be balanced. However many atoms of one element that you have in your reactants, you have to have in your products somewhere, even if it has different partners. So a couple things. We need to make sure that there are the same number of atoms of each element on each side of the equation. So how we do this is we add coefficients. Sometimes we'll get the urge to change the formulas, but we cannot change formulas of the substances. We can only change these things called coefficients. So we're going to work through a few examples with some visuals here. So in this reaction, hydrogen plus chlorine yields hydrochloric acid or hydrogen chloride, however you want to refer to it. They have the same formula. We have H2 plus Cl2 yields HCl. So in looking at this, if we have an H2, which is right here, plus a Cl2, which is right here, and it yields HCl, we can see right away that we have two green circles on the left, but only one on the right, and two yellow circles on the left, but only one on the right. So if we were to be adding or combining H2 and Cl2, we would actually get two HCl molecules. Now, how we demonstrate that in our chemical reaction is we put coefficients in. So from one H2 molecule, we were able to get two HCl's. And from one Cl2 molecule, we got two HCl's. So the coefficient is demonstrating that we get two HCl molecules. And we write coefficients in front of the compound that we're talking about. Another way to see this that I'd like to show you guys is by building the HCl. So let me scooch this up a little bit. So if H2 plus Cl2 yields HCl, well, if we break these things apart and actually form our products, you can see very quickly that there are two HCl molecules, 1 and 2. So that's why we put that coefficient in front of the HCl. The next equation I'm going to do with you deals with water. So the equation that we're going to do is hydrogen plus oxygen yields water. And the chemical or the formula equation for this one is H2 plus O2 yields H2O. So I'm going to use these little molecules to help demonstrate what's going on again. So we have an H2 plus an O2, and the product that I'm going to build is an H2O. So if you notice, if we break apart this H2 and O2, let me scooch it up. So if we break apart the H2 and the O2, and H2O forms, so we have a hydrogen that goes here, a hydrogen that goes here, we end up having one oxygen left over. But oxygen, a single oxygen, is not one of our products. H2O is a product. So it actually requires, in order to only get H2Os as a product, we actually need another hydrogen. So I'm going to bring this down here, and we're going to build H2O. And so we got two H2O molecules from one oxygen molecule, and we actually had to use two H2 molecules. So I'm going to write in the coefficients. We got two H2Os, and what we used, and I'll rebuild our reactants here, we used one O2, and whenever you only use one of something, you don't have to actually put the coefficient of 1. down. You can simply just leave the compound as is, and the 1 is just understood. So we got 2 H2O molecules from 1 molecule of oxygen and 2 molecules of H2. So I write the 2 in front of the H2. Now, sometimes what students want to do, and let me scooch my molecules back up. I'm going to erase this balanced equation here. So sometimes what students want to do is they'll see, okay, there are 2 hydrogens on the left side of the arrow, and there are 2 on the right. So the hydrogens are balanced. There's 2 oxygens on the left, and there's only 1 on the right. So all I have to do is put a 2 right there, and now it's fully balanced, except our product was water. Our product was H2O molecules. If you change that subscript, it changes what the substance is. H2O2 is actually hydrogen peroxide and has different properties than what water has. So unfortunately, we cannot just change the subscripts. We do have to keep the chemical formulas of the original substance. The only thing that we can do is change the coefficients out front of each substance. So if we have 2 hydrogens on the left and 2 on the right, and that looks good and balanced, and then we have 2 oxygens on the left but only 1 on the right, we would then have to put 2 as the coefficient in front of H2O. That would balance our oxygens, but it unbalances the hydrogen. So then we have to double back and think, what times 2 equals 4 hydrogens, which is what we get from 2 H2O molecules. And the answer to that is 2. So we put the coefficient of 2 in. I'm going to work through a couple more examples. If we take a look at this one, we have N2 plus H2 yields NH3. I'll show you guys a different method of thinking about this. What we can do is list out each of the elements that are on each side of the equation. So in this particular equation, we have nitrogens and hydrogens involved. And then you want to count up how many of each element you have, how many atoms of each element you have. So on the left, we have 2 nitrogens, so I'll write my 2 here. We have 2 hydrogens. And on the right, we only have 1 nitrogen, so we put a 1 here. And we have 3 hydrogens, so we put a 3. And right away, you can see these things are not balanced. So you can really pick either one, the nitrogen or the hydrogen, and take the steps to balance it. So since I wrote nitrogen first, I'm just going to do the nitrogen first. So on the left-hand side of the equation, we have 2 nitrogens. On the right-hand side, we only have 1. So how do we get 2 nitrogens? Well, we would have to add a whole nother molecule of NH3. So we would need 2 NH3s. Now in doing that, we now have 2 nitrogens, and it also changes our number of hydrogens. Because if we have 2 molecules of NH3, then we've now doubled our hydrogens. A way to remember what to do when you have a coefficient with that comes before something with a subscript is you can simply multiply the coefficient and the subscript, and then you'll get your tally. So 2 times 3 equals 6 hydrogens total. If it helps, you can also draw out your compounds, and then you can add them up. Okay, so 3 plus 3 equals 6 hydrogens. So it's up to you how you want to tackle it. So now our nitrogens are balanced, but our hydrogens still need some help. There are 6 on the right-hand side of the equation, but there are only 2 on the left. So here you want to think, what times 2 should be our coefficient? So if there are 6 hydrogens on the right-hand side, then what times 2 equals 6? And the answer is 3. If we have 3 H2 molecules, then that equals 6 hydrogen atoms total. So that changes this number to 6, and now our hydrogens are balanced. As a visual here, if you take a look at these little bins, if we have N2s and H2s, and it makes NH3s, and you take a look and see that right now there's 2 nitrogens on the left here. Let me actually put the plus sign in the arrows. There are 2 nitrogens on the left, but only 1 on the right. So what we would have to do is grab another product, NH3. Now we have 2 nitrogens on the left and also 1 and 2 nitrogens on the right. So that's balanced. And if you take a look here, we have 2 hydrogens, but over here we have 1, 2, 3, 4, 5, 6 hydrogens. So we need 6 hydrogens total on the left-hand side of the equation. So we can add 1 more hydrogen. Now we have 4. 1, 2, 3, 4. And then if we add 1 more, now we have 6. 1, 2, 3, 4, 5, and 6 total hydrogens. So then our balanced equation is N2 plus 3 H2s yield 2 NH3s. And you can see how that works there. I'm going to go through these 2 equations, and then if you need more help, there will be another tutorial video posted where I go through more equations. So I'm not going to use the tally method. I'm just going to do everything out loud and add coefficients as they're needed. So if you take a look on the left-hand side of the equation, there's 1 xenon. On the right side, there's 1 xenon as well. So this is good to go. On the left side of the equation, we have, whoops, I don't think I wanted to put the check mark on this one yet. But on the left-hand side of the equation, there are 2 fluorines. On the right, there are 6. So you want to think to yourself, for this coefficient, what times 2 is equal to 6? And the answer is 3. And that balances the equation. So there's 1 xenon and 1 xenon. 3 times 2 equals 6 fluorines on the left, and because of this subscript, there are 6 fluorines on the right. So this is the balanced equation for that first one. Next up, we have Na plus Cl2 yields NaCl, or sodium plus chlorine yields sodium chloride. So here we have 1 sodium on the left, and there's also only 1 on the right since we don't see a subscript. So that's balanced. For chlorine, there's 2 on the left, but only 1 on the right. So we have to put a 2 in the front of this substance so that there are 2 chlorines on the right. So now the chlorines are good, but we've now misbalanced our sodium. So we have to double back. There are 2 sodiums on the right, so we had to put a coefficient of 2 in front of the 1 on the left. If you have any questions, please let me know. Otherwise, there will be another video posted of me going through more examples.